All right, more solving exponential equations in example 3. The first thing, recall, we were instructed to do was to isolate the exponential term on one side. We're going to accomplish that by subtracting 4,200 from both sides. All right, so now we have 10 to the 5 plus 8x equals 84,000 minus 4,200 is going to be 79,800, I believe. Okay, and so now we are ready to take the log or natural log of both sides. And again, I decided I'm going to do the natural log of both sides of my equation. Okay, so what we have now is the natural log of 10 to the 5 plus 8x power equals the natural log of 79,800. Okay, move that up a little bit here. Now, once again, take your exponent, which is those two terms there, and move it down front. Okay, so we're going to have the quantity, let's go ahead and write it as a quantity, 5 plus 8x multiplied by the natural log of 10 is what is remaining, equals the natural log of 79,800. Now, it's just a matter of doing some algebra to get in there and solve for x. First of all, I'm going to go ahead and divide both sides by the natural log of 10 to get that number off of there. Okay? So I'm left with 5 plus 8x equals the natural log of 79,800 divided by the natural log of 10. Now we got to do some algebra again to get in there and solve for our x. I think we need to subtract 5 from both sides first. Okay? Then we will have 8x equals the natural log of 79,800 divided by the natural log of 10 minus 5. And then divide both sides by 8 to solve for x. Divide each of those two terms by 8 or the whole side by 8. And there is our exact answer. That's our exact answer, okay, for x, which they probably want us to get an approximation. And let's go again to 4 decimal places, okay? So, going to my calculator, I'm going to move it over so I can actually see what I'm supposed to be punching in here. I'm going to, first of all, take the, let me go ahead and get this number right here, okay? I want to find what is the natural log of 79,800. Oh, I got too many zeros there. All right. There we go. 79,800, I'm going to divide that by the natural log of 10. Okay? And that's this right here. From that, I'm going to subtract 5. And then I'm going to divide all that by 8. And to 4 decimal places. 1, 2, 3, 4. I'm going to keep that to be a 2. So negative 0.0122. Negative 0.0122. Okay? On our next example, 24. Oh, okay, this is good. Almost isolated. The variable that we're solving for is almost isolated. The first thing I'm going to do is divide both sides by 320. Okay? So on the right-hand side, I have e to the negative 0.05t. Okay? Now on the left-hand side, I have 80 over 320, which I believe that reduces to 1/4. Now, definitely since this is a base of e, I definitely here want to take the natural log of both sides. Trust me, y'all, we want to do that. Okay? So on the left-hand side, I've got the natural log of 1/4. Now, this is where you can apply your quotient rule if you would like. Okay? Over here on this side, this is the same thing as the natural log of 1 minus the natural log of 4. Okay? And recall that the log or natural log with any base of an argument of 1, that is just 0. So 0 minus the natural log of 4 is just a negative natural log of 4. Okay? Okay, now let's go over here and let's simplify this right-hand side. On the right-hand side, I've got the natural log of e raised to the negative 0.05t. Now, bring that exponent down front, and we'll have negative 0.05t multiplied by the natural log of e. Now, if you punch in the natural log of e on your calculator, remember that this is the same thing as the log of e with base e. Anytime the base and the argument were the same, that was just 1. The natural log of e is 1. If you want to pause the video and punch that in on your calculator, you sure can. Okay, so 1 times negative 0.05t is just negative 0.05t. One more little step here to solve for t. Divide both sides by negative 0.05. Negative 0.05. Now, a negative over a negative is a positive, so our exact answer is going to be the natural log of 4 divided by 5/100ths. And once again, they're probably going to want us to give an approximation to maybe 4 decimal places. So I'm going to take the natural log of 4 and divide that value by 0.05. All right, so let me get over here and take the natural log of 4 divided by 0.05. And to 4 decimal places, I'm going to round that up to a 9, 27.7259. 27.7259. I think that looks pretty good. That's rounded to 4 decimal places. Oh, no. Oh, no. Ah, you know what we did the whole time? Oh, crap, I'm going to have to start this video over. Okay, so you know what I decided to do instead of waste 8 minutes of my life? I'm just going to edit this. What we did wrong here, what I did wrong here is this is 0.5, not 0.05, so the decimal goes here. It goes here. It goes here. It's 0.5, okay? It's just 0.5, it's 0.5, it's 0.5, it's not 0.05, it is 0.5, edit that. And so what that's going to do, I'm just going to divide this by 0.5, that's going to make this 2.7 instead of 27 point. And I forgot what the rest of it is. 2.772, that would go to 6. 2.7726. And the rest of it is right. Okay, so there we saved a little bit of time, or at least I did on my life, and I appreciate you, allowing me to do that. Okay, so that's the correct. Watch out. Don't let your old lady eyes fool you. Okay.